Welcome back, students. We'll be looking at section 4.5, Practice for Solving Systems of Linear Inequalities. Problem 1. So remember in the previous video when we were learning how to solve these problems, I did individual graphs for each of the lines and then showed you how to put them together. And we're going to continue with that process in these practice problems as well. So the first thing I need to do is get all of my equations into the y equals mx plus b form. So I'm going to subtract 4x here. I get 0 plus 5y is greater than or equal to negative 4x plus 20. Rewrite that. Divide everything by 5. And I end up with y is greater than or equal to negative 4/5 x plus 4. I'm going to rewrite that over here since that's this equation, and we'll need that for graphing. I'm also going to go ahead and write it here so that we'll have it later. Let's go ahead and graph this line. Our starting point is 0, 4. That's our B. And then we're going to use our slope to find our second point. So I'm going to go down 4 over 5. So my second coordinate is here. Our inequality has the or equal to. So that tells me it's going to be a solid line. And now we need to use a coordinate to find our shading. So I'm going to use the origin since it's not a part of our line. I'm going to say 4 times 0 plus 5 times 0 is greater than or equal to 20. That's 0 plus 0. 0 is greater than or equal to 20. Is that true? No. So that means our shading is going to be on the other side of the line. So go to my highlighter and I'm going to put green over here. So these are the solution sets for this particular line. All right, now let's solve our other equation for y. I'm going to subtract x from both sides. I get 0 minus 2y is less than or equal to negative x plus 5. I'm going to rewrite that. Divide everything by negative 2. End up with a y, and then remember, if we divide by a number that's negative, we need to flip our inequality. So that becomes greater than or equal to. This becomes a positive 1/2 x. We get a minus 5/2. I'm going to rewrite this 1/2 x. And that minus 5/2 becomes a minus 2 1/2 just so we can graph it. So I'm going to write that over here now. Y is greater than or equal to 1/2 x minus 2 1/2, and I'm going to write it here so it's there later. 1/2 x minus 2 1/2. All right, let's go ahead and plot up here. We're going to go down to negative 2 1/2, so we're going to be halfway between that negative 2 and that negative 3. When we do our slope, we need to go up a whole 1 to right here in between, and then go over 2. So our coordinate is actually going to be height-wise between negative 1 and negative 2, right up under that 2 on the x-axis. We have the or equal to, so it's going to be a solid line like this. Now let's figure out our shading. We can use our origin since it's not a part of the line. So I'm going to move this up just a little bit. All right, so I'm going to put 0 minus 2 times 0 is less than or equal to 5. 0 minus 0. 0 is less than or equal to 5. That is true. So that is where our shading will go for this particular one. So I'm going to shade right here. All right, so now remember to show how they relate to each other. That's what I'm about to do now. So I'm just going to quickly plot them because we've already done that. So let's see here, 4, and then I went down 4 over 5, and it was a solid line. And then for my next one, it was negative 2 1/2, up 1 over 2. It was right there. Solid line. All right, so now let me fill in my highlighting. For our first line, the highlighting was right here. For our second one, the highlighting was right here. And so now we can see where we have blue and green highlighter is right here. That is the only place that we have both colors. So that is going to be our solution area. So I'm just going to fill that in with yellow. This is our solution area. So solution, remember on the computer, that is the only place that you fill in the shading for these types of problems, because you're only shading the area that they share. Problem number 2. All right, I have x is greater than or equal to 2y plus 6. I have my 2y on the right-hand side. I kind of want it on the left. So I'm just going to flip the whole problem. So 2y plus 6. I'm going to make sure I keep the inequality pointing towards the way it was before. It had the point of it pointing towards the 2. So I want to keep that pointing towards the 2. And the open mouth of the inequality pointing towards the x. That way I don't change any values. I'm just flipping the problem. All right, so now what I can do is subtract the 6 from both sides. I get 2y plus 0 is less than or equal to x minus 6. Divide everything by 2. And I get y is less than or equal to 1/2 x minus 3. All right, let's go ahead and write that over here. So y is less than or equal to 1/2 x plus 3, or excuse me, minus 3. I almost rewrote it incorrectly. Minus 3. Go ahead and plot that. So go down to -3. Use my slope. Go up 1/2. I got my coordinate there. This has an or equal to in my inequality, so it's a solid line. Now I'm going to figure out where my shading would go. Since the line's not through the origin, I can use that. So I'm going to say 0 is greater than or equal to 2 times 0 plus 6. So 0 is greater than or equal to 0 plus 6. 0 is greater than or equal to 6. That's not true. So that tells me my shading is going to go on the other side. So I'm going to put my shading over here. All right, let's look at our other equation. We already have it in the proper format, so I don't have to do anything with it. I'm just going to rewrite it so we can see it better. So we already have it there, and we already have it there. Let me put this one here real quick. I forgot to do that earlier. All right, now let's plot this one right here. We have plus 4, so that's right here. My slope is a -2. I'm going to put it over a 1, so we have a fraction. So down 2 and over 1, that's my second coordinate. It's a greater than, doesn't have an or equal to with it, so this is going to be a dotted line. And now I'm going to use the origin to find where my shading will go. So I get 0 is greater than -2 times 0 plus 4. 0 plus 4. So 0 is greater than 4. Nope, that's not true. So that tells me my shading is going to go on the other side. So it's going to be right here. All right, now let's go ahead and plot both lines so we can see how they relate. So I had the -3 here and then up 1 over 2, and it was a solid line. And I had my other one was up 4, down 2 over 1. It was a dotted line. All right, now let's do our shading. My first one had its shading down here. My second one had its shading right here. And I can tell that the area that they share, where they overlap, is right here. That's where they have solutions that will work in both equations. So what I'm going to do is just shade this region here. That is my solution area. All right, problem number 3. We're going to do the same thing. We're going to get our equations in the proper format. This one is like the other one where I want to flip the whole thing. So I'm going to write 4y plus 3 is greater than or equal to x. The open mouth was pointed towards the 4y, so I want to keep it pointing towards the 4y. I'm going to subtract the 3. That gives me 4y plus 0 is greater than or equal to x minus 3. Rewrite that. Divide everything by 4. And I get y is greater than or equal to 1/4 x minus 3/4. I'm going to write that over here. I'm also going to write that right here so that we can use it later. All right, let's go ahead and graph this. We're going to go down to -3/4. That's between the 0 and the 1. It's not quite to 1. I need to go up 1 from there and then over 4. So we're going to be roughly right here. I have an or equal to, so I'm going to connect them with a solid line like this. Redo my little coordinates so y'all can see them. All right, now we need to figure out our shading. Since the line does not go through the origin, I can actually use the origin. So I'm going to put in 0 is less than or equal to 4 times 0 plus 3. 0 is less than or equal to 0 plus 3. And 0 is less than or equal to 3. That is true. So that's the side that our shading will be on. So we'll shade that side. All right, let's do our next one. We have x plus y is greater than 0. I'm going to subtract the x from both sides. I get 0 plus y is greater than negative x plus 0, which is y is greater than negative x plus 0. I'm going to keep the plus 0 just for graphing purposes. Put that there. And put that one there. All right, let's go ahead and graph this. My slope has an invisible -1 there. And I'm going to put that over 1 just so I have a fraction for a rise over run. So my starting point is 0. I'm going to go down 1 over 1 for my next coordinate. I do not have the or equal to, so this is going to be a dotted line. Since my origin is part of my line, I can't use 0, 0. So I need to use a different coordinate. I'm going to use 1, 1. So I'm going to use this one here. So if I say 1 plus 1, that becomes 2 is greater than 0. That is true. So my shading is going to be on that side with that coordinate that I chose. All right, now let's plot both lines on the other graph and see how their shading interacts with each other. So I had the -3/4 here, up 1 over 4 for my second one here, and it was a solid line. My other one was a 0, down 1 over 1, so it was right here, and it was a dotted line. All right, so for shading, for my first one, my solid line, my shading, my green shading was here. For my dotted line, my shading was here. And I can tell that I have blue and green where they overlap right here. That is my solution area. So I'm just going to put shading here. That's the only area that they share. So that is my solution area. All right, let's look at problem 4. I have 3 lines here that I need to graph. So let's start with the first one. I'm gonna go ahead and write it again right here so we can change it into the proper format. Subtract x from both sides. I get 0 minus 2y is greater than or equal to negative x minus 2. Rewrite that. Divide everything by that negative 2. And when we do that, we need to flip our inequality because it's a negative number. And that gives us a positive 1/2 x plus 1. All right, so I'm going to write that above here just so we have it to look at when we go to plot the line. And I'm also going to write it next to this one down here when we graph them all together. All right, so let's go ahead and graph this one. We start at +1 here. Use our slope to find our second one, so that's up 1 over 2. We have the or equal to, so it's going to be a solid line. I can use my origin, since it's not a part of the line, to find where my shading goes. So I'm going to plug in 0 minus 2 times 0 is greater than or equal to negative 2. 0 minus 0 is greater than or equal to negative 2. And 0 is greater than or equal to negative 2. Yes, that is true. So my shading is going to be on that side. So let me pick my highlighter here. So I'm going to shade over here for that particular line. All right, let's look at our other 2 equations. My x is less than or equal to 3. I don't have a y. So what I need to think through is this a horizontal or a vertical line? Well, it's telling me my x is less than or equal to 3, which means I'm going to cross my x-axis right here. So this tells me it's a vertical line. It's less than or equal to, so it's going to be a solid vertical line at that location. So let's draw that. Now I need to figure out where my shading will go using my origin. So if I plug in and I say 0 is less than or equal to 3, is that true? Yes, that is true. So my shading will be on this side. All right, let's look at our other line. Y is greater than or equal to negative 2. Same situation, I only have a y. So I need to figure out, is this a horizontal or a vertical line? Well, it's going to be on the y-axis at negative 2. And it's crossing that y-axis, so that tells me it's a horizontal line. It has the or equal to, so I know it's a solid line at that location. And now I just need to figure out where my shading goes. So if I plug in 0 is greater than or equal to negative 2, is that true? Yes, that is true. And so my shading is going to go up in that area, like this. All right, let's look at putting all 3 of them together. So my first one was +1, up 1 over 2, and it was a solid line. My next one was a horizontal line at 3, and it was also a solid line. And then my last one was a, excuse me, did I say horizontal line for the other one? I meant vertical if I said horizontal. That was a vertical line. My last one is the horizontal line at negative 2, and it was also a solid line. Okay, let me draw this line a little bit further and this line a little bit further so that we have their interactions better. There, that looks better. All right, so now we need to go back and look at our highlighting. For our first number we had, or for our first graph, we had the red down all the way down here. The next one we had green, and it was going this direction. So far it looks like we have shared location right here. But we need to put the blue on there so we can see where all three of them share. So the blue one was up this way. All right, so in this location, we only have blue and green. We don't have the red, so that's not our solution area. This area, we have blue and red, but no green. So that's not our solution area. This one, we have red and green, but no blue. So that's not our solution area. The only area that we have all three is right here in this middle area, this triangle. So I'm going to take out the highlighting, and we're going to fill in just this area right here. And then I'm going to erase the little bit of extra that showed up, just so it doesn't confuse. So let's take out that little bit extra, because our shaded area is our only solution area that would solve all three of these equations. Well, now that we've done 3 lines, how about for our last problem, we do 4 lines? So it's not going to be any more difficult. It's going to be the same process. We're just going to have 4 lines with shading this time instead of 3. So let's go ahead and start with our first one. That 2x minus 3y is less than 6. Subtract 2x from both sides. I get 0 minus 3y is less than negative 2x plus 6. Rewrite that. Divide everything by negative 3. End up with y is, I'm going to flip my inequality because it's a negative number, becomes greater than 2/3 x. 6 divided by negative 3 is a negative 2. Now I'm going to write that over here so we have it for graphing. I'm also going to come down here and write it here. All right, going back up to where we were, let's plot this particular graph. So I'm going to go down to negative 2, go up 2 over 3 with my slope to find my second one. This one does not have the or equal to, so it's going to be a dotted line. And I'm going to use my origin to find my shading. So I'm going to put 2 times 0 minus 3 times 0 is less than 6. 0 minus 0. And we get 0 is less than 6. And that is true. So my shading will be on that side. So I'm going to shade here, this whole area for that line. Do the second one. We have x plus y is greater than 3. Get my x on the other side. So 0 plus y is greater than negative x plus 3. So that's y is greater than negative x plus 3. That's the equation for this one. So I'm going to go ahead and write that. So y is greater than negative x plus 3. I'm also going to write that down here. Y is greater than negative x plus 3. Box this one in. I forgot to do that. All right, so let's go back up here and plot this one. We have plus 3, which is right here. My slope has an invisible negative 1 there, so it's actually negative 1 over 1. So I'm going to go down 1 over 1. I don't have the or equal to, so I'm going to use a dotted line. And then I'm going to use my origin again to find my shading. So let's see here. Let me scroll up a little bit so I can actually do the work. So 0 plus 0 is greater than 3. 0 greater than 3. No, 0 is not greater than 3. So my shading is going to be on the other side of my graph here. All right. let's talk about the next two. We have x is less than 4 right here. This is going to be either a horizontal or vertical line because there's only the x there. The x must be less than 4. It's going to cross our x-axis right here. So I know I have a vertical line. It's going to be dotted since it doesn't have the or equal to. So let me draw a dotted line here. And then we need to figure out where our shading is going to go. And we can use our origin. So if I say 0 is less than 4, that's true. So my shading is going to go on this side for this particular graph. Okay, now look at the next one. We have y is less than 4. So I'm going to go to 4 on the y-axis. That tells me it's going to be a horizontal line. It's going to be dotted because it doesn't have the or equal to. And now I can figure out my shading by using my origin. So if I put 0 is less than 4, that is true. 0 is less than 4. So my highlighting is going to be in this area with that coordinate. All right, now let's take all 4 of those and graph them on this graph right here. So I had the -2 up 2 over 3. It's a dotted line. And let's see, I had my shading at the top of that one. So I'm going to go ahead and do that while we're here. I'm just going to go ahead and shade right here. All right, our next one had +3, so we're right here. I went down 1 over 1 because our slope was a -1 over 1. It was also a dotted line, so it's shaded there, or excuse me, it's drawn there. Our shading was above that line, so I'm going to shade here. So far, it looks like we have a shared area right here, but let's keep going and make sure that is in fact where we're going to share our shading. We have 2 more lines to graph. We had a vertical line at 4, so right here. It was also dotted. And the shading for it went this way. All right, so it's still looking good for this particular area right here. So we'll just have to see if that's where the yellow also ends up highlighting. Our yellow graph had the line graphed at 4 on our y-axis right here. And it was a horizontal line at that location that was dotted. And our shading for that one went this way. And the area where all the colors are is right here in the middle in this triangle. So that is our shared space. So I'm going to take all of the shading off. Oh, nope. Let's see here. I'm actually going to end up having to redraw it real quick. Bear with me, guys. I did it out of order. So let me draw our lines real quick again. All right, so I've redrawn our lines. So now let's put in our shading. I think I'm going to use the pen this time instead of the highlighter just because it'll be easier to shade just this little area. So the only area is right here in this triangle. So this is our solution area. All right, let's look at our Bible verse. And all those who had believed were together and had all things in common. And they began selling their property and possessions and were sharing them with all, as anyone might have need. Acts 2:44 through 45. All right, guys, I hope you're having a great day. I'll see you in the next video. Bye.